I'm Anil Kumar. Welcome to my series on vectors. We'll try to understand dot products in greater details now. Well, we know that if I have a vector A dot B is basically equal to magnitude of A times the magnitude of B times cos of theta, where theta is the angle between them. Now that is basically geometric interpretation, right? So this is when we know the angle between the two vectors. So we say it is geometric representation. Now the idea is that if I am given two vectors whose coordinates are given to us, then how are we going to solve the question? So what we will do here is we'll take a xy coordinate, we'll work in 2 dimensions first, and then we'll try to figure out how to do it in R3, right? So let us consider that the two vectors which we have are vectors A and B. Let's say this is our vector A, and then we have a vector B. These vectors are at an angle theta, right? And let's call this as, let's close it up with vector C, right? So let us say we are given vector A, vector B, and this is vector C, which in this case will be vector A minus vector B, correct? Clear? Now from the geometric interpretation, we can say A dot B is magnitude of A times magnitude of B times cosine theta. But now, if I don't give you the angle, and if I give you the coordinates, then how are you going to work? Let us say I give you that the vector A is basically equal to general coordinate. Let's take A1, A2. And we give your vector B as equal to B1, B2. Now if that is given to you, how do I find the dot product? That is the question, right? So we know A dot B is magnitude of A times magnitude of B cosine of theta, but we don't know what cos theta is since we are given the coordinates. You get my point, correct? Well, from here we can definitely write that vector C in this situation will be what? Will be A minus B, or I can say A1 minus B1, comma A2 minus B2, correct? So that becomes my vector C. Now definitely to get to the angle, I will have to look into cosine law. Since we have a situation where we are given side, angle, and side, right? So we know vector A and B, and we need to figure out the angle theta in between. So that means we have to now look into sine law, cosine law, and then figure out, can there be a way to relate the coordinates with dot product? That's the whole idea. So I hope you have understood the concept, right? Okay, now what is cosine law? Cosine law says that c square is basically equal to a square plus b square plus 2ab cos of theta, right? So cosine law says c square equals to a square plus b square minus 2ab cos of theta. Right, that's what cosine law says. Now when I'm applying it to two vectors, I'll take these as my vector magnitudes. Does make sense to you? Right, so that's why I left some space in between, right? So when I apply the same thing, we're saying magnitude here is magnitude of vector A, magnitude of vector B, right? That's what we have, and the angle in between. So applying the cosine law, we get c square equals to a square plus b square minus 2ab cos theta, right? The two magnitudes, right? So if I rearrange, I get 2 times vector A magnitude times vector B magnitude cos theta is basically equal to magnitude of A square plus magnitude of B square minus magnitude of C square. Correct? Now, we can actually take 2AB in the denominator, but since we know that A dot B is AB cos theta, right? So what I will do here is I will retain AB cos theta on the left side and see what it is. So now I could write this as magnitude of A times magnitude of B times cos theta is basically equal to magnitude of A square plus B square minus C square over 2. Perfect. Now, what is AB cos theta? As per our definition, magnitude of A times magnitude of B times cos theta is A dot B. So what we get here is basically A dot B. Do you see that? So the left side is A dot B for us. That is how we relate, right? Does it make sense to you? So we got A dot B here. Now, we actually don't know C. We are not really, we are interested in A and B. So what we will do here is we'll replace this C by those terms. Correct? So what we get here, the magnitude of A, which is what? Well, let's try to look into it. When I say magnitude of A whole square, it really means A1 square plus A2 square, correct? Similarly, magnitude of B is B1 square plus B2 square, where A1, A2 and B1, B2 are the coordinates of A and B, position vectors. I've placed it at the origin. You get the idea. Vectors can be placed anywhere, right? So that is what A square, B square magnitudes are. So I'll replace them with A1 square plus A2 square, and for B I'll write B1 square plus B2 square. Correct? So I have got the coordinates A, B now. Do you see that? And even for C, those are the coordinates. So I'll take squares of these. So what I have here is A1 minus B1 whole square plus A2 minus B2 whole square. Does make sense to you? Everything divided by 2. So we finally get A dot B equals to what? Let's expand this. So we have A1 square plus A2 square plus B1 square plus B2 square minus, here let's expand, we get A1 square minus 2A1B1, right, plus B1 square. And this gives me A2 square minus 2A2B2, right, plus B2 square. So that's what we get, right? Now, in this you can see that A1 square minus A1 square cancel, A2 square cancels with A2 square, B1 square cancels with B1 square, B2 square cancels with B2 square. What are you left with? Well, all this was divided by 2, right? This 2, okay. So we get A dot B is basically equal to what? Minus makes them positive, both of them, right? So we get 2 A1B1 plus 2 A2B2 divided by 2. Now we can take 2 as a common factor, so we get A1B1 plus A2B2 divided by 2, right? Which is only A1B1 plus A2B2. It's a scalar quantity. Do you get the idea? So finally, we actually could now find the dot product using the coordinate points. So A dot B is basically equal to A1B1 plus A2B2. You get the idea. So that is how we could derive an expression for dot product when we are looking into a coordinate system. Now the same calculation can be extended in R3. So this is in R2, right? So in R3, what will be the case? In R3, we'll have the dot product of vectors A and B will be equals to A1B1 plus A2B2 plus A3, B3, correct? Where A and B are in R3, right? So A1, B1, A2, B2, and A3, B3 is going to be the dot product in R3. Does make sense to you, right? So that is a very important derivation, and I hope you understand how we get from a geometric definition this algebraic Cartesian vector solution, right? So we could actually use dot product to solve the questions when we are given the Cartesian vectors. In R2 or in R3, right? So that makes sense to you? So that is a very, very important relation, and we are going to use this dot product in this fashion whenever the coordinates are given to us. So I hope that helps. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.